Okay guys, here we go again. This time we're going to start from the opposite. We're going to start with a velocity versus time and go back to a written description, or I'll probably just say it instead of writing it. So if we're looking at this velocity map, let's look to see what we can figure out before you even start. We know right here that between 0 seconds and 2 seconds, we have a velocity of 0. We know between 2 seconds and 4 seconds, we have a velocity of positive 2. And then we know our last segment is going to start at 4 seconds and goes to 8 seconds. And we have a velocity there of negative 1. Negative 1. So I like to just write it out very basic to begin with. So I'm going to come here and I'm going to put segment A, what I know, and it's 0 meters per second. That's the first thing I know. I'm going to come here and put segment B, and from segment B, I know that that velocity is going to be 2 meters per second. And at segment 3, I'm going to call that segment C, I know that it's negative 1 meters per second. So negative 1 meters per second. Here we go. I'm going to try to scoot this down. It's hard to bend. So if I'm right here, I'll also know, if I'm looking at segment A, that it happens between 0 seconds and 2 seconds. And remember, our seconds are always going to be our x values. So I'm going to come right here, and I know that's going to be 0 something. I know this is going to be 1 something, and I know this is going to be 2 something. I know that for sure because of my time, right? If I look at segment B, I know that segment B happens between 2 seconds and 4 seconds. So 2.0001 or whatever, all the way to the beginning of second 4. So I know that that's going to encompass second 3 and 4, 3 to 4. And then if I look at segment C is going to start at 4, but I've got 4 there, so it's like 4.1 to 5. So I know that segment C is going to be 5 something, 6 something, 7 something, and it stops at the 8th second. So an 8 something. Now to go from there. If this has a 0 velocity, I know that means it's not going any distance at all. If it's not traveling any distance, that means it's at 0 meters. So that means this is going to have to be 0, 0, 1, 0, and 2, 0, because time is still passing, but the distance is not. Okay, I'm just going to label these up here too so we know. Okay, if I look here at segment B, oh boy, segment B is moving at 2 meters per second. Okay, so the first thing I need to realize is my starting meters right now is 0 meters at this point, and I'm going 2 meters per second. So if I'm at 0 meters, that means the second that passes, I'm going to be at 0 plus 2 is going to be 2. And there's another second there, and that means that my next second that passes is going to be also 2 meters per second. So 2 plus 2 is going to give me 4. Okay, that takes care of segment B. If I look down here at segment C, I know that it's got to be negative 1 meters per second. That tells me that it's headed in the negative direction, or down, back towards the origin, most likely, or 0 meters. And it's moving at 1 second per 1 meter per second. So if I'm going from 4 as my starting point for segment C, 4 meters, and I'm going 1 per second, that means I'm going downward. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. And 1 minus 1 is 0. So that should give me my coordinates to be able to plot. Now I'll move this over. Next thing I want to do is I want to take that to position versus time. And just from looking at this, I know that my highest y value, which is my distance, is a 4. Because I have 0, 0, 0, 2, 4. Then I go 3, 2, 1, 0 again. So I'm just going to come and I'm going to try to make it a little larger force. So I'm going to make this 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2, 4. And we know that this is meters, because that's our distance. I'm going to make this right here is my time. And we know that we have a total of 7 or 8 seconds. 8 seconds that have passed. So this is seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It keeps going. Okay. Now I just need to plot my points. 0, 0, 0, 0, 1, 0, 2, 0. Now I'm coming here, I'm going 3, 2, 3, 2, 4, 4, 4, 4. Then I go to 5, 3, so 5, 3, 6, 2, 6, 2, 7, 1, 7, 1, and then 8, 0. And then I just connect them. Sorry, my lines aren't perfect. Oh boy, I don't have any stops right there. But this will be segment A, segment B, segment C. Now, I do not have to solve for my velocity or do rise over run because I know it right here already. I'm given my velocity. So now I need to take this information and I need to create a motion map. To create the motion map, or the ticker tape is another word for it, I'm going to come right down here. And remember, this line represents your meters. I only have to go to 4 meters. But I'm going to try to make it a little bigger for us this time. 0 meters, 1 meter, 1, 2, 3, 4, 5, 6 meters. And then I just want to look at those again. I know that I'm starting at 0 meters because right here I have a 0 velocity at 0 meters. So here's 0, 0, right? I'm also going to have another 1, 0. I can tell from right here too. And then another one at 2, 0. Just like this. My next one, or my third second, is going to be at 2. Remember, this is 0 seconds, 1 and 2. So my third one's going to be at 2. And my fourth one's going to be at 4. My fifth one is going to be at 3. 3. And then I'm going to go to 6, 2, 7, 1, and then this will be 8, 0. All right, so I'm moving at 2 meters per second here. That's 1 second, 2 seconds. I'm going to go ahead and make that come right there. I can't leave that a blank dot because it would show that we have stopped. This is just a quick turnaround, so I'm going to pull that one right down here. And I'm going to connect these. So this is 4, 5, 6, 7, and 8, which corresponds to everything that we have if we're to plot those coordinated pairs again. Remember this, the dots are our time and the lines are our meters. So it would be 0, 0, 1, 0, 2, 0, 3, 2, 4, 4, 5, 3, 6, 2, 7, 1, and 8, 0. That corresponds to what we have here and over here as we've done each one of those. And so now we have taken a velocity graph to position versus time to a ticker tape. Now, the next thing we want to do is come up with a written description. I'm not going to write that out in the interest of time, or maybe I will, but it would be something like this. Renee decides to give Jake a head start, so she waits for 2 seconds. Here she's waiting. There's no line, 0 and 1. 1 second, 2 seconds. Then she sprints at 2 meters per second for 2 seconds before she realizes she forgot her lipstick. So she quickly turns back around and jogs back at 1 meter per second. And do you see that is described by the motion that's happened on each one of these? Or you could make it simple. You could say as an object waits at the origin for 2 seconds, then moves 2 meters per second for 2 seconds, and returns to origin at 1 meter per second. Any of those would work. Hopefully this gives you a little help.